the best way to show how a D flip-flop works is to actually just simulate it. And so what we have here is another Wokwi design. We have a D flip-flop where we have a clock signal coming into this symbol here, this triangle, that's the clock. And then we have our data into here, and then our output is Q. And the LEDs are set up so that when the signal is high, the LED turns on. Now, just a few things is that we're going to take the clock two different ways. I can press a button that will give me a rising edge when I press and let go, or I can have a free running clock at 10 kilohertz. Then there's something called a reset. Let's just simulate it. So, in this particular simulation, Q will be set to some value automatically. You can't always trust that, but there you go. The reset is high, and in fact, we're not using it in this this simulation, but you click it, and you see that that middle LED goes off, and then it goes high. So in other designs, that sets all the flip-flops to a known value. Not in this particular case. The clock, we can kind of do a rising edge where I click it, the clock goes on, and then I let it go. And so it goes to 0. So it's important for the D flip-flop to have the rising edge. So right when I click it, there's a rising edge, and then it stays on, and then I let it go. I can keep that on. Now, I can also have the clock running freeform, and it's actually 10 kilohertz. So I can move the switch, and the LED is like, for the clock, is constantly on. In reality, it would be on half the time, and the LED would be half as bright, something called pulse width modulation. I don't think there's a difference. That's like a certain level of brightness. Then I turn it to here. I can't tell if it's really half brightness. I don't think the simulator is doing that. What this allows us to do is step through one clock cycle at a time. So when I click this button, it's low, then it goes high, and when I let go, it goes low again. All right. And then here, the first input, it's 0. And notice I can change the D as much as I want, and nothing happens until I get a positive clock edge. And as soon as I press that button, it assigns Q from D, and now it's high. All right? Now I can turn off D as much as I want, turn it back on, and nothing happens to Q until the next clock cycle. Now, if you turn this clock on, it's going to look like Q is getting D instantaneously. Right? I'm clicking it off and on. But what's happening is this clock is going on off and on so fast you can't see it at 10 kilohertz. And so as soon as I click it, it's being passed on. To really see if the D flip-flop is working properly, you have to just set it. And of course, if the data doesn't change, the clock can change and Q remains where it's at. So I would download this file and just get used to all these buttons and how Q is getting D at the rising edge of the clock.